Hi. So for the first question in this exam paper, we've been asked to prove the following identity. Okay, so it doesn't really matter what side we start on, but it is best to start on the side which is a little bit more complicated so that we can reduce this down into the side that is a little bit more simple. Okay, so what we're going to do is we're going to start from the left hand side and we're going to reduce this down to the right hand side. Okay, so the first thing I can write is from LHS, which stands for the left hand side. So this just shows the examiner that we're going to be starting from the left hand side and we're going to be working our way to prove that this is identical to the right hand side. Okay, so I'm going to say 1 minus tan squared theta over 1 plus tan squared theta. Okay, so you should see that the denominator of this fraction is very similar to one of our standard trig identities, and I have it written here, Q layer 1. So this is a standard trig identity and you should be familiar with it. Sec squared theta is identical to 1 plus tan squared theta. Okay, so this can be derived from the identity sine squared theta plus cos squared theta is identical to 1. If we divide all the terms in that identity by cos squared theta, we can derive this identity. So that's a nice way to remember how to derive it. Okay, so what I can do is I can say that the denominator can be rewritten as sec squared theta. Okay, because sec squared theta is identical to 1 plus tan squared theta. Okay, so I can say this is identical to 1 minus tan squared theta, that doesn't change. And the denominator we said is identical to sec squared theta. Okay, so what I can now do is I can now separate this fraction, okay, because the two terms on the top share the same denominator. So I can say this is identical to 1 over sec squared theta minus tan squared theta over sec squared theta. Okay, so what I'm going to do now off to the side, because this part can get a little bit tricky, I'm going to bring this off to the side and I'm going to say tan squared theta over sec squared theta. Okay, so now let's think about what the constituents of tan and sec are. Okay, so this is identical. Tan squared theta is sine squared theta over cos squared theta. Sine squared theta over cos squared theta. Okay, and this is being divided by sec squared theta. Now sec squared theta, you should know, is 1 over cos squared theta. Okay, so when we divide two fractions, we think about KFC. Keep, flip, change. We keep the first fraction the same. We flip the second fraction. So 1 over cos squared theta becomes cos squared theta over 1, and we change the sign to a times. Okay, keep, flip, change. Now, cos squared theta divided by cos squared theta is just 1. So this is identical to sine squared theta over 1, which is just identical to sine squared theta. Okay, so we've shown that tan squared theta over sec squared theta reduces down and is identical to sine squared theta. Okay, so I'm just going to put that in there. We can also say that 1 over sec squared theta, we know that is just cos squared theta. Okay, and we've just shown that tan squared theta over sec squared theta is identical to sine squared theta. So we have minus sine squared theta here. Okay, so now you should see that this is in the form of one of our other trig identities, Q layer 2. Cos 2 theta is identical to cos squared theta minus sine squared theta. Okay, this is our cos double angle identity. Okay, so if I just substitute that into the last line, we can say that this is identical to cos 2 theta. Okay? And then we've shown that this is identical to cos 2 theta. Okay, thank you very much for listening, and I'll see you in the next video.